Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 6th grade topic, proportions. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. Now, if you have any question but we see it today, or even your own homework, you can always put it in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. This video should be a rather short one, so leave a like, smash the subscribe button, and let's get started. Now we're going to start off this video asking a very simple but important question. What is a proportion? Now, at this point in time, you should know that proportions and ratios have this invisible red line of fate that ties them together. And if you don't know what a ratio is, you're not going to understand at all what a proportion is. You have to know what a ratio is because proportions, quite honestly, you wouldn't have proportions without ratios. So if you have no idea what a ratio is, no worries. I have a video that explains exactly what a ratio is right up here, and you can check that out and then come back to this video when you feel more confident with your knowledge about ratios. Now, if you're still with me, you should know what a ratio is at this point in time. Now, proportion is just going to be in its most basic form when you have two ratios that are equal to each other. Now, I say in its most basic form with a little caveat because when you have proportions, you have units that you have to take into account. Now, your units have to be in a special way, but we'll talk about that a little bit later in this video when we're talking more about the constraints. So right now, we're just going to focus on what it is at its most basic form at a high level. So stay tuned and you'll see more about those constraints a little bit later. So we have two ratios that are equal to one another. And when this happens, we say those ratios are in proportion to one another. When two ratios are equal, we say they're in proportion to one another. So how do proportions look? We talked about proportions being when ratios are equal to one another. So how do we write a proportion? Well, you have to first write your ratios. And we have a few different ways of writing our ratios, one of which is our colon form and another is our fraction form. So we're going to focus on those two forms. So let's say we have the ratio 2 to 3. And we have another ratio 4 to 6. And you can write this also as 2 over 3 and 4 over 6. So these mean the same thing. If we know that these are equal to one another, if we know that these are in proportion to one another, we can quite literally write them like this. You just put the equal sign. Remember, when these two fractions or ratios are equal to one another, they are called to be in proportion to one another. So simply writing equal would suffice. This is especially true when you have them in their fraction form. When you have fractions that are equal to one another, we can call those fractions equivalent fractions. Well, when you have ratios that are equal to one another, instead of having equivalent fractions, we can say they're equivalent ratios. So when you have equivalent ratios, equivalent lets you know that you're going to be having an equal sign in there. So this is how you can write your proportions. However, there is another way you can write proportions that might not necessarily be used widespread nowadays, but it is still used in some areas, however rare it may be. And I wouldn't be doing my job if I didn't let you know what that looks like. So instead of writing an equal sign, when you have the colon form, you can actually write a double colon. This means the same thing as equal. Now, it could be pretty confusing when you write it like this. However, this is another way that some areas, maybe some old textbooks or maybe some areas online, will tell you that these two ratios are equal or in proportion to one another. So whether you see your equal sign or you see this double colon thing, know that that means these two ratios are in proportion to one another. However, for this video, we're going to stick to equals. Now, your proportion has different parts. Mainly two parts to be concerned with, and they're called the means and extremes. Now, what are the means and extremes of the proportion? Well, the means is going to be the inside numbers. So these two numbers of your proportion are going to be the means. And the extremes are going to be the outside numbers of your proportion. So these two numbers on the outside are your extremes. So E, and that's going to be an M. So the extremes and the means. The last thing I want to talk about in this video is going to be the constraints on your proportion. Now, these two constraints I'm going to talk about really keep your proportion the way it needs to be. And that is, it needs to have ratios that are equal. And we make sure they're equal with these two constraints. So make sure you're paying attention to this last part, because if you miss this, you might get something that is not necessarily a proportion. So the first constraint that we're going to talk about deals with the parts of the proportion we just discussed, the means and extremes. So let's bring back the example that we had here. So 2 to 3 equals 4 to 6. Now, I said that this was true, but we haven't verified this. Our first constraint allows us to verify that this is indeed true. And that is because our means and our extremes, they have a constraint on them that when you multiply your means and extremes, they have to be equal. If when you multiply your means together, you do not get what you get when you multiply your extremes, you do not have two ratios that are equivalent. So let's verify that what I said about this is indeed true, that this is a proportion and that these ratios are equal to one another. So our extremes, we said on outside, so that's 2 times 6. And we want to make sure that that equals 3 times 4, which is going to be our means. So what's 2 times 6? Well, we know that to be 12, right? 3 times 4 is also 12. So if 12 equals 12, we know that this is indeed a proportion. The product of our means equals the product of our extremes. That is the constraint, the first constraint that you're going to need to know to make sure that you do have a proportion and not something else. Now, some people may know this constraint in a different form. Let's say we don't have this colon form, but we instead have fraction form. There is a way that we can use our fraction form and still test this constraint out. Now we have our fraction form here. Is it easy to determine what your means and extremes are when you write it in this form? It might not be. However, we have another way of verifying that when you do multiply the means and extremes together, you indeed get the same number, if it is actually a proportion. And that is using cross multiplication. If you have no idea what cross multiplication is, no worries. I also have a video on that. You can check it out right here. Cross multiplication is a very easy tool that we can use to verify that two fractions are equal. And if these fractions are actually ratios in our case, two ratios are equal. So in order to do that, our cross multiplication pretty much says that we're going to multiply these numbers and these numbers. And if that gives us the same thing, we are going to have two fractions, or in this case, two ratios that are equal. So 2 times 6 equals 3 times 4. Now we always write this equal sign here whenever we're doing cross multiplication. We're going to bring this same equals down here that we have, and we always write that. Now, is that actually equal? We'll see. And if it's not, we'll cross it out. But whenever you do cross multiplication, you always have to have your equal sign here. So 2 times 6, that's 12. 3 times 4, also 12. So we can keep our equals because this is indeed equal. So the first constraint dealt with the means and extremes, the parts of our proportion. The next constraint is going to deal with the units of your proportion. Now, when you're talking about the units of your proportion, they can show up in a few different ways. So here are some examples that your units can show up and will still allow you to have a proportion. So if your units do not look like this, your constraint is going to tell you that you do not have a proportion. The reason being is because your second constraint is telling you that if you have two units, all of one unit has to be on one side and the other unit has to be on the other side, or you have half and half going. So one unit on the top, one unit on the bottom, but the same unit has to be on the top on the other side and the same unit has to be on the bottom on the other side. If you have one unit like this, then it doesn't really matter. Everything is the same, so you can almost drop off the unit in that case. So in this case, it's fine to be unitless because all the units are the same. But if you have two different units, they have to show up in one of these two forms. Let's say you had an example that had a setup that wasn't one of these three setups that we talked about here. You're going to see that that example can't guarantee that your ratios are equivalent. So we're going to use the same fractions, 1 over 2 and 2 over 4. Now, the reason why I said your units are important is because of this right here. Normally, you would say, yes, these are in proportion to one another because 1/2 and 2/4 mean the same thing. But when you throw units in, that's not always the case. So let's say you had same, so whatever that unit is, and different here, right? This unit is different from that one. And we're saying that this is the same unit that's down here, and this is the same unit that's up here. This setup is not one of these three setups. So notice this different here. This different is the same exact unit that's up here, and notice that the value attached to that unit is also the same. However, we're saying that this is equal, and although these units are the same, their numbers are different. This is showing you that your ratios are not in fact equivalent. Although the fraction form looks like it is equivalent, their meaning betrays it, and therefore this is not a proportion because these ratios are not equal. So you have to stick to one of these three setups when you're dealing with your units. If they're all the same, you can drop all the units and it's fine. But if you have two different units, they have to be one of these two right here. So I hope you're following today's examples, and I hope you see that your proportions are going to be just the next step when you're dealing with your ratios. As long as you understand what your ratios are, you can easily find out whether they are proportioned to one another or not. However, if you have any questions about what you saw today or even your own homework, you can always put in the comment box below or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found this video helpful. And if you found it helpful, so can somebody else. So hit that like, smash subscribe, hit the notification bell, and while you're at it, share the video with a friend. Well, that's all the time I have for today. I'm really hoping to help with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.